let me have a go at this question. So you have that function, it's a polynomial function, and you have different parts. First part is solving the equation equals 0, derivative, find the derivative equals 0, and look at the sign of the derivative for depending on the power. So any of you had a go at part A? Alright, let me continue with that question. Any of you know how to do part A? Nice one, Angelo. To use a NOR factor law, you use a factorized form. Why do you need to expand that? Do not expand anyway. You do not know the value of n and m. Alright, so part A, you leave it as it is. And when you solve f of x equals 0, you don't need to worry as it is as a power. The power just gives you the number of repeated solution. Okay, so for part A, when you have f of x equals 0, you look at, you have two repeated factor, x equals alpha and x equals beta. Okay, so like that. I don't know where you get A and B from. Is that your alpha beta? Okay, part B. Is that where you got stuck? How do we differentiate that? Oh, D. Okay, so part B is stripped. So part B is what you need to do is you use the product rule. So you define F as the product UV. U is the first repeated factor, and V is the second repeated factor. You use a chain rule. Okay, notice the coefficient of x is 1, so that makes it easier when you use the chain rule, but if you don't know, you need to practice that. So u prime is going to be the derivative of that polynomial, so it's n bracket to the power of n minus 1, and you substitute the inside by the expression, and you need to multiply by the derivative of that expression, which is 1. So that's why there's nothing else after that. V prime is m x minus beta bracket to the power of m minus 1. Okay, now we can rewrite it's u prime v plus uv prime, so that's the derivative. So that's gonna give me Hang on, what did I do? I hope I'm right. Okay, common factor is going to be x minus alpha, x minus beta to the lowest power for each term. So the lowest power is n minus 1, and for x minus beta is m minus 1. What's left is going to be n and 1 of that factor, and the other term is m with x minus alpha. Okay, let me pause that because I think somebody now hopefully I have the correct derivative. Okay. I need to leave it factorized. Now here I'm gonna regroup the like terms because we need to solve that equals 0 in a second. So that's gonna be m plus n bracket, that's the factor of x, and after that I don't know, doesn't matter what order I leave it. I guess m alpha minus n beta, just to be kind of in alphabetic order. Alright, so that's part B. Part C, we make it equal 0, so defactorize. So you have the two factors that gives you alpha and beta. So the first two solutions come from the factors to the power of n minus 1 and n minus 1. X equals alpha, x equal beta. And the last one, again, you use the null factor law. It's an expression in x. So m, alpha, n, and beta are just constant or coefficients, so they're not the variable you're after. You make that equal 0, and by making x the subject, that is x equal to the opposite of that. So that's m alpha plus n beta. And it's going to be a fraction because we're going to divide by m plus n. Now, is that correct? Because it matters. I need to know that I have that kind of correct. Okay, now do I leave it like that? So there's a few more information. So m and n are positive integers. M is greater than n. Do we know anything about the values of alpha and beta? Like, are they just real numbers? Okay, so D1I, what we know is m and n are odds, so if they odd, something you can do if you were to do that with using algebraic expression is you can, when you want to express a number to be a variable to be odd or even, use a notation for even it's 2 times 2n, and for odd it's 2n plus 1. Here, because we have m and n, do I worry about this or not? Because that's odd. Okay. I'll leave it like that. Alright. So m and n are odd. You know what it implies? What happens if you add 1 or minus 1 to each one of them? Correct. So what we're gonna have is, I'm looking at the derivative. I'm looking, because that's what we want to do. We want to find the derivative in equation. We're just looking at those two factors. So m minus 1 and n minus 1 would be even. What it would imply is those two, hang on, you can't see. So for the derivative here, if those two powers are even, what it means is the first two factors have to be positive. So what it means is this. X minus alpha to the power of m minus 1 is positive. It's going to be the same as x minus beta to the power of n minus 1 is positive. So the derivative, the sign of the derivative to be positive, will be independent of those positive factors. It will only depend on the last factor, which is this one. Okay, so what it means is that factor has to be greater than 0. We can divide by m plus n. We do know that they are both positive, so the sum is going to be positive. So if I divide by that positive factor, that inequation will not change. Okay, so first we transpose that on the other side, and then we divide by m plus 1 being positive, so x has to be greater than m alpha plus n beta divided by m plus n. That's a constant. You can figure it out from the values of mn, alpha, and beta. I hope that's the answer for 1i. Yes, sorry, I forgot about that one. So yeah, to get that, obviously, oh, because it's strictly greater than 0, correct? So we also need to add that, so x different from beta. Okay, probably have to do that for 2i. Okay, is that it for 1i? I hope so. 2i. M is odd. If m is odd, it implies that m minus 1 is even. M minus 1 even means x minus alpha to the power of m minus 1. That's one of the factors of the derivative is still positive. It's still greater than 0. By the way, yes, you should, Elia. I was doing that extra question, but Louis, it's not just beta, it's also alpha. Because if x is equal alpha, it will make the other factor 0 as well. So that's positive. So we can ignore that factor, that positive factor. Now if n is even, is that right? It means n minus 1 is odd. It means that being odd, we need to look at the sign of that as well. Okay, so if you have n minus 1 is odd, it means n is even. So if we take I think I did it backwards. Hang on, m is odd, but m is the power of beta. Let me fix that. That's beta. Okay, what it means is that power of n minus 1 is also how do I want to factorize. I'm going to do this: x minus alpha times x minus alpha to the power of n minus 2. Okay, now the n minus 2 is even, so this part is greater than 0. What's left is a factor x minus alpha and the remaining factor. So for f prime to be positive, what we need is 1 factor x minus alpha times m plus n bracket x minus m alpha minus n beta greater than 0. Okay, and the now it's going to be a little bit tricky. Now that's a quadratic that is factorized. It's a normal quadratic, and if you graph it, if I graph that, this bit, so if I draw f prime, now I need to know which one is greater in terms of, there's two x-intercepts. Now I think they're both gonna be positive, so it's gonna be, it's a normal U-shaped parabola. We need nothing. Yeah, there's a minimum here, but I don't really care. What we do is we're looking for the sign of the derivative anyway. So to be positive, you have your two intercepts. You have one is from alpha, that's alpha. The other one, I assume, I don't, because I know nothing about alpha and beta. All I know is m and n positive and m is greater than n. But I know if alpha and beta are different signs, that could change its position over here. I don't know. So it's going to be m alpha plus n beta over n plus n. Okay. To be positive, you need to be less than alpha or greater than that. Okay. So graphically, what I can say is x is from negative infinity to alpha excluded, because we don't want that to equal 0, to this value m alpha plus n beta over n plus n to positive infinity. Okay.